Hello. In this lesson, we're going to do some deriving. In the definition, from the definition, we have figured out so much information in the past weeks about these trig functions and arc sine, arc cosine, arc tangent, arc cotangent. And in these sections, we're going to talk about what else can be derived and in the algebraic forms, okay? And of course, as always, whenever we discuss trig functions, we're discussing this on the stage set, which is all the angles are measured from standard position. Positive angles are measured counterclockwise and negative angles are measured clockwise, all from the standard position. And the note we talk about here that all the input angles or output angles, they are all measured in the same way, following the same rule. And reference angle, of course, is the positive acute angle between terminals and axes. And definition is going to be, is still going to be the same situation. If A is an angle in standard position and a point X, Y on the terminal side of angle other than the origin, right? So we have the definition for sine, cosine, tangent, cotangent, secant, cosecant. Now let's see algebraically what can be derived. Okay. Now the first one, right? I'm going to regroup these in the following order. Okay. So I'm going to switch. So I'm going to put a cosecant in the position next to sine. And tangent, cotangent are going to be in the position together. Okay. And cosine, and the secant. I'm going to pair them this way. Okay. And on the next side, of course, they're going to be done accordingly, right? R over Y, right? That's for cosecant. Cosine is X over R. And the secant is R over X. Tangent is X over Y, Y over X. And cotangent is Y. Oh, sorry, is X over Y. There we go. When we arrange it this way, when we rearrange it in this way, it's still the same 6 definitions for trig functions. But if we look at each pair, if we found that they are just reciprocal to each other, they're reciprocal to each other. Cosine and secant, they are reciprocal to each other. And tangent and cotangent are reciprocal to each other. So let's see what else we can derive. And we claim that all the domain requirements are satisfied, okay? Assume that all the domain requirements for specific functions, for all the functions involved, all functions involved are honored. Okay, so we don't have any domain concern. Okay, there will be no violation. So let's look at for each pair, right? For sine and cosecant, right? If we multiply, because they're reciprocal to each other, right? They're reciprocal to each other. So sine of A multiply cosecant of A. Okay. So please have your paper pencil with you and derive it alongside with me. So sine of A is Y over R. And cosecant of A is R over Y, multiply. And y reduce, r and r reduced, and therefore we get that equals to 1, right? So this confirmed that they are reciprocal to each other. So we get identity, sine of an angle multiply cosecant of an angle is equals to 1, the same angles, okay? So that equals to 1. And we box it. Oops. We're gonna box it. And next, they're reciprocal to each other, right? So from it, we get sine of A, sine of any angle is equals to 1 over cosecant of A. And what is more, another relationship, cosecant, oops, cosecant of A is equals to 1 over sine of A. Okay, so this is true for any angle in the respective domains. Next, right? For cosine and secant, similar relationship also satisfied. Okay, so once again, if we take cosine, multiply secant, and once again, we will have x over r multiply r over x. So this once again is equals to 1. Okay, so we got another identity. Okay, there's so many identities we can derive, but please, okay, don't try to memorize them. Just derive them along my side. You will know it. You don't need to spend time to memorize them. Okay, only you need to do it. Okay, do it once or a couple of times. You will remember. You will remember. You don't have to do the memorization part. Okay, so cosine of A of any angle is equals to 1 over secant of A. And the next one, okay, so secant of A is equals to 1 over cosine. Okay, now for tangent, similar, right? If you like to pause here and do your own deriving and come back to check your answer, feel free. Okay, so tangent multiply cotangent is equals to y over x multiply x over y. And that equals to 1. Okay, so once again, we have that relationship, that tangent multiply cotangent, and that equals to 1. And the next one, tangent is equals to 1 over cotangent, and cotangent is equals to 1 over tangent. Okay, so you can see these are deriving actually, if you put your hands on it, it's actually not that difficult. You don't need to memorize. It's right there. It's right there. Okay. The next very important identity is this one. Sine squared plus cosine squared of any angle. They're the same angle. Okay. And it's equals to, we plug in. Okay. And we plug in, we square both sides of both top and bottom, and we add the numerator. And because r is defined this way, therefore r squared equals x squared plus y squared. As a result, the sine square of angle plus the cosine square of the same angle is equals to 1 for any angle in the for any angle. Okay. Now here I want to put a note here. Okay, there's some algebraic notation that you must make sure you understand what they are. For example, sine square of a means sine of a multiply sine of a, or it means sine a times sine a. Okay, cosine square of a means similar. However, sine a squared, if you put the square along, you know, only for the input, then that means sine a times a. So they are different. So this piece and that piece are not the same thing. Now, with that observation, right? We have sine of a, cosine of a, and we also find out that tangent is the same as sine over cosine. Cotangent is cosine over sine. With that observation, we can derive some more identities, okay? Knowing that, okay, knowing these, okay, knowing sine squared plus cosine squared of a, same angle equals to 1. From here, we can derive, we can divide, if we divide every term, by cosine squared of a, provided it is not 0. Okay, everything in domain, they're all honored, right? So here, this equals to tangent of square of a plus 1 equals to secant square of a. Okay, so this is another very useful identity. In similar manner, we can divide both sides by sine squared. Okay, by sine square of a, provided that we're not dividing by 0. As a result, okay, we get 1 plus cotangent square of a equals to cosecant square of a. So we get another identity. Okay, we get another identity. So these are some of those important identities we have so far. Okay, this is some of those important identities we have so far. And next, we're going to summarize on these identities. Okay, so this is a brief summary. So we have this piece, that piece, right? And the sine square plus cosine square equals to 1. So we have these 3 pieces, right? That's one group. The other groups are like this piece, okay? And the next piece. And the next one. You can see they're all derived from definition. Okay, so these are some of these identities we can get straight from the definition. Okay, what else can we get from the definition, right? So suppose we're interested in double angle, half angle, and sum of angles and difference of angles and so on and so forth, right? From product to sum, or difference, from difference to product, which is a factoring. In those cases, do we have formulas for them? Excuse me. Yes, the answer is yes. Okay, so we're going to derive that. We're going to derive those formula in the next, I think in the next lesson. Okay, I'll try to break this into smaller lessons so you can have, you know, so when you watch it, it doesn't feel so long. Okay, so I'll see you guys in the next lesson. Thank you for watching.